Hello, welcome back. Today we're going to be talking about applications of graphing in slope-intercept form. The objective is that by the end of this video, you should be able to graph a function from a problem situation. So looking at a problem situation, we're going to try to create a graph. Suppose you want to buy an electronic book reader that costs $200, and the books for the reader cost an average of $10 each. The total cost of the reader is expressed by the equation CB, meaning the cost of the books, or the total cost, is $200, that's the price of the reader, plus 10 times B, meaning $10 per book, where C is the total cost and B is the number of books. We're asked to graph the equation that we were given, or graph the function. The good news is, anytime you're asked to graph an equation, and you're given an equation, all you have to do is graph this. However, this isn't really in a form that we're used to seeing. If it makes it easier, you can rewrite the equation so that y stands for CB, meaning y is going to be our total cost, equals 200 plus 10b. Now, we don't normally write b, so we can change the b with x. This isn't necessary, but it does make it look more like something we're used to graphing. In order to graph the equation, we could make a table, which would be easy enough, or we could write the equation in slope-intercept form, giving us y equals 10x plus 200. I'm going to choose to graph the equation in slope-intercept form, and I'll show you why here in a second. I'm going to start my axis off like this. Notice I have no negative values. I'm not going negative in the x direction or in the y. That's because our total cost will never be a negative amount of money. Neither will we be buying negative books. So I make my axes both positive. In order to graph the equation, we need to start at 200 on the y-axis because that's our y-intercept. So, in order to skip some values, I'm going to draw a little squiggle line and a dash and put 200, meaning I'm going to start at $200 on my y-axis because that's the initial cost of the book. Draw a point. My rise over run, notice it's 10x, so I make it 10 over 1 to give me a rise over run, which means that my rise will be 10 and my run will be 1. Now, when you're asked to graph an equation and they didn't give you a graph, you get to choose your scale. So I'm very conveniently going to choose to count by tens. So this will be 210, this will be 220, this will be 230, 240, and so on. On the x-axis, I'm going to count by ones. So, if my rise is 10 over 1, I'm going to go up 10 and to the right 1. I can do that again, going up 10 and to the right 1. Up 10 to the right 1, and so on. Now, before I connect the dots, is this a continuous function? Can you buy half a book? The answer is no, so your function would just be a series of dots going in a linear fashion. To review real quick, the way I graph the equation is I rewrote the function so that I had y's and x's, something I'm used to graphing. I then rewrote it so that it was in slope-intercept form. I plotted my y-intercept and I used my rise over run to find a series of points. I did not connect my dots because it was a discrete function, not a continuous function. Okay, on the x-axis, we need to label our graph. The x-axis, in this case x, stands for b, or the number of books. So I'm going to label my x-axis, number of books. My y-axis stands for the total cost. In this case, our cost is in dollars. So now we've finally graphed the equation that we were given from a problem situation. So let's extend it a bit. Suppose we're given the following instructions. Part B of the question we just got through working. You're thinking of buying a reader that costs $230 with the books costing the same amount as the other reader. Now what we're going to have to do is we were asked to graph it on the same graph. So I'm going to rewrite the function again. CB equals 230 plus 10B. I'm going to write that as y equals 230 plus 10x. Get it in slope-intercept form. I get y equals 10x plus 230. My y-intercept is going to be 230. My rise over run is going to be the same as it was in the previous problem. So I'm going to go up 10 and over 1. The pattern will continue, going up 10 and over 1, over and over again. It will also be a discrete function because you still can't buy part of a book. What is the difference in total cost between the two readers? Notice, the first reader cost $200, this reader costs $230. Since the books cost the same amount, the difference should be $30. Is that supported by the graph? Look at the graph. These points should always be separated by 30. Is that the case? From 230 to 200 is separation of 30. So the difference in cost between the two readers would be 30. Again, right here, they're separated by amount of 30, and 30, and 30, and 30. So if the difference in cost between the two readers is $30, does that difference in total cost change, or is it always the same? Well, just thinking about the problem, you know that the first reader costs $200, this reader costs $230, so that change will never be different. So it will always be the same. And again, that shows up on the graph as the points being separated by the same amount every single time. Here's a problem for you to try on your own. Note that you are given the function that you are asked to graph. Go ahead and try to graph the function on your own and compare it to what I get here in a moment. Please press pause, graph out the function, and press play when you're ready to see the answer. I went ahead and started graphing it for you. Note that you're going to start at 500 as your y-intercept, because that's the initial amount that they're going to charge you to work on your car for parts. Then every hour you should go up $80. And I chose to count by 80s on my y-axis to make that part of the graphing easier. Now before you connect your dots, always ask yourself the question, is this a continuous function? Can you be charged part of an hour of labor? The answer is yes. So we will, in this example, connect our dots.